Hello, this should be the concluding part of the Laws of Indices lesson, and today I'll be teaching the power law and the root law. As you have seen here, when a number is raised to a power, which is raised to another power, the number is said to be in power. So in order to arrive at the final result, you copy the base and multiply the indices. Now for the root law, is a way of obtaining the root of a number. For instance, if I have, it could be, which could be square root, cube root, fourth root, or whatever. Let me quickly demonstrate that. The first one is the power law. The power law. I could have c to the power of x raised to the power of y. Or to achieve my final result, I'll copy my base, which is c, and multiply my indices, which is going to be x multiplied by y, which is c x y. I've always said it that in mathematics you can use any figure to depict anything. You don't have to be stuck with the a, b, or you can use hem, you can use n, q, or whatever. They are just alphabets to show or to depict something. So don't get stuck with the x and y syndrome. So let's use real figures. If I have 2 to the power of 2, which is in turn raised to the power of 4, what I do is to copy my base, which will be 2, then multiply my indices. That's 2 multiplied by 4, which is going to be 2 to the power of 8. Then we can have a squared raised to the power of, let's say, 5. What I do is to copy my base, which is a, and multiply my indices, which is going to be a to the power of 10. So here again I have, let's say I have 3 to the power of 0 raised to the power of 4. What I do is to copy my base, which is 3, and multiply my indices. That's 0 multiplied by 4, which is going to be 3 to the power of 0. 3 to the power of 0 is 1. All this we can actually verify, like I've said in the first lesson. Indices are just simpler ways of doing calculations with large numbers. For instance, I can verify this. 3 to the power of 0 is 1. Don't forget, anything to the power of 0 in mathematics is 1. So 3 to the power of 0 here is 1. So I have 1 raised to power 4. 1 to the power of 4 means multiply 1 in 4 places. Multiply by 1, multiply by 1, which is actually still going to be equal to 1. So indices just help us to do our calculations faster than when we have to deal with large numbers. So let's treat the root law. Now, with the root law, you have a raised to the power 1 over m equals to now in this case we have a numerator and we have a denominator. What you do now is to look for the nth root, which is going to be the denominator. That's m roots of the number given, then raised to this power, which is 1. In the case of roots, usually the numerator will be 1, but sometimes some textbooks will differentiate between the root law and the fraction. That's if the numerator is not 1. Sometimes it could be a to the power of, let's say, n over m, where this n is not equals to 1. I'll treat both examples, but in this case, let's focus on when our numerator is going to 1, which is going to be the root law. So now, I can have, if I have, let's say I have 4 to the power of 1 over 2. You know, 2 is square. So this is like saying the square root of 4. So now I have, my answer will be 2. What I'm just trying to say is, what will I multiply in 2 places? That will give me 2. So square root of 2 of 4 is actually 2. You know, usually when we are writing square root, if it's square, we don't usually include these 2. But for the sake of explanation, I have included it. So now I have 2 raised to power 1, which is going to be equals to 2. So if I have 9, 1 over 2, I just write this straight. It's the square root of 9 raised to power 1. Square root of 9 is 3. It may not be square root, it may be the cube root. If I have 27 1 over 3 is raised to power 1 over 3. Let me rewrite this. It's too big. Raised to power 1 over 3 is the cube root. So now I have to write the 3. It's only when we are writing square root that we don't include the 2. So now I have 27 raised to power 1. Cube root of 27 is 3, because what will you multiply in 3 places that will give you 27 is 3, because 3 multiplied by 3 multiplied by 3, 3 multiplied by 3 is 9, multiplied by 3 equals 27. So the answer, cube root of 27 is actually 3. So the only difference between this root law now and the fraction law, like I've said, is when the numerator is now equals to 1. Is not equal to 1. So let's take an example like that. Like we have 125 to the power of 2 over 3. You can see that my numerator is not 1. So now the answer to do this now, we have the cube root of 125, everything raised to power 2. Cube root of 125 is 5. What you multiply in 3 places that will give you 125? This is it. 5 multiplied by 5 multiplied by 5. 5 multiplied by 5 is 25. 25 multiplied by 5 is 125. So it's 5, then raised to power 2. 5 to the power of 2 is 5 multiplied by 5, which equals to 25. So that's the only difference. You can have as many examples as you can think of. I want to believe that this video has helped you. You can share with your friends. Like my Facebook page for more. And I will see you guys later. Thank you.